Okay, this is number 6. On number 6, the worst thing you can do is from the first step, absorb this 1 into the numerator. That's not going to get you where you're going, and it's absolutely 100% incorrect as well. So don't do that. That's not the right thing to do. What you need to do is find a common denominator. So if you start out with 1 minus tangent squared over 1 plus tan squared, and you're adding 1, what you need to turn that 1 into is a fancy 1 of 1 plus tan squared over 1 plus tan squared. If you do that as your first step, this proof actually gets really easy. It's very few steps. So now these two fractions we can combine over the common denominator. I have 1 minus tangent squared plus 1 plus tangent squared over 1 plus tangent squared. You cannot cancel the 1 plus tan squared in the numerator with the 1 in the denominator at this point, because in the numerator you're adding. You have all that addition and subtraction, and canceling is division. So make sure that you're not canceling at this point. What you want to do instead is combine like terms. So if you look at your numerator here, you have a negative tangent squared and a positive tangent squared, and those cancel. And you have 1 plus 1, which is going to give you 2. That's good news, because in our goal over here, we have 2 cosine squareds. So I have 2 over 1 plus tangent squared. And remember our goal, I like writing that out every once in a while, is 2 over 2 cosine squared. All right. At this point, I would think 2 different ways. I would think, one, if I could change tangent squared into sines and cosines. That seems like it might help since I have cosines on the other side. But that also introduces sines into the mix, and that might make things a little messy. The other thing you always want to think about is your Pythagorean identities. If you remember your Pythagorean identities, you have sine squared plus cosine squared equals 1. You have 1 plus cotangent squared equals cosecant squared. And 1 plus tangent squared, which we have right here, is equal to secant squared. Remember, those two are linked. So you can change that 1 plus tangent squared into secant squared. And that's awesome news, because secant squared is the reciprocal of cosine squared. So 2 over secant squared is the same as 2 times cosine squared. And I've had students have a hard time seeing that in the past. What has helped is doing something like this. You can always break up a fraction when it's all multiplication. And once I show that, a lot of students are able to recognize, oh yeah, that is definitely cosine squared. So that proof looks a little daunting at first because of all the tangent squareds and because you have to find a common denominator, but it's really not that bad.